In this tutorial, we are going to deal with patterns with a constant difference. Right, what do we mean by patterns with a constant difference? Right, we mean that patterns that actually you just keep adding a specific number to get the consecutive term. All right, so in this case, we have this pattern which is represented by pictures. All right, so you can basically count the number of the matchsticks. Right, so uh, the first uh, term there, okay, you can see here that there are about about 4 matchsticks, and then followed by this picture over here, right, where you now have about 8 matchsticks, and then followed by this here. Okay, so where you can see that you have about, let me circle that again. Right, where you have about 12 matchsticks. So for figure 1, you can see that you have 4 matchsticks. Figure 2, you can see that you've got 8. And then figure 3, you can see that you've got 12. So if I write this properly on the side, we've got a pattern that is starting with 4, then followed by 8, then followed by 12. So to check for the constant difference, we can see that, okay, we need to take the, for example, I would say that's term number 1, okay, term number 1, and 8 is term number 2, right? And then 12 will be term number 3, okay? So to find the constant difference, so we need to say, okay, term number 2 minus term number 1, which will therefore be 8 minus 4, and that is going to be equal to 4, right? And you can check by subtracting the other consecutive terms as well. So for example, you can take 12 minus 8, and then you will find that it's 4. So since every time you minus or subtract between 2 consecutive terms and always find that you've got the same difference between those terms, right? So we will call the number 4 to be what we call the constant difference, right? So that is a constant difference. All right. So how do we work with patterns that have a constant difference? It means that for each consecutive term, you need to keep adding the number 4. So for example, there you got you got the, at number B there, you got a table that you need to complete. And it says, okay, for figure 1, the number of matches, okay, there you've got 4. For figure 2, you've got 8, and then for figure 3 you've got 12. So how many will you have for figure 4? You just add 4, so you would have basically 16 if you add a 4 there, right? And then for 5 you will have 20. Okay, now there is a quick way of working this out. Instead of first finding, the first and second term and then keep adding 4 many times. Example, if you're asked in this case, find what figure 10 is, how many matches is it gonna have? All right, so there's a formula that you need to know. All right, the formula for the general uh, term, okay, so which is Tn equals to A plus n minus 1 times the constant difference D. So A in this case is the first term, and then D is the constant difference. So that's the constant difference. And then N, what is N? N is the term number, okay? Term number, right? For example, when I say T1, I mean term number 1, okay? So now, after we found the constant difference, we can go and apply all that information into that formula. So I will start by rewriting the formula again. So I will say Tn, right, equals to A plus n minus 1 times D, right? N just means that any term number, okay, any term number, any term number. So, which means we can say the general term for this pattern is going to be Tn equals to, what is the first term of the sequence is 4. Okay, plus the n minus 1 remains like that. And then the constant difference was also a 4. Right. So please note that this 4 for the constant difference is not the 4 that we're starting with. Okay. That's the first term. Constant difference means, okay, the number that we keep adding, to get the next term. Okay, we kept adding a 4. So that's the constant difference. Okay, so afterwards, then I must work out and simplify this expression. So Tn is equals to 4. Then if I multiply that 4 inside the bracket, I must multiply it to there and multiply it to there. All right. So then I will say, okay, 4 times positive n, I'm going to get positive 4n. And then I say positive 4, all right, this 4, positive 4 multiplied by negative 1, I'll get negative 4. Okay, so afterwards I group the like terms, then I'll have 4n plus 4 minus 4. The final answer I'll get, okay, 4 minus 4 is 0, so I'll just end up with 4n. Okay, so that is the general term for this for this pattern. Okay, which means that, okay, if I'm going to find term number 10, I'm going to say term T10, which means term number 10, is equals to 4. Instead of n, I'm going to put 10 times 10. Right, 4 times 10 is definitely equals to 40. So I can find any term number, no matter how big it is, just by putting that term number in the formula that I found. So this has now become my general equation. So what if they've asked me to get, for example, okay, to get term, okay, so if they asked me to get, let's say maybe term, they say get term number 50, okay. So I was going to say term number 50 is obviously going to be 4. Instead of n, I'm going to put 50. So every time they ask for a specific term number, instead of that term, you put, instead of n, you put that number. So which means this was going to be equals to 200, right? It's as easy like that. All right. So if you want to see if this works, you can try with each and every one of those term numbers that you already been given. So for example, for figure 1, we would have said, okay, term number 1 equals to 4 times 1, which will give us 4. For term number 2, we would have said, okay, equals to 4. Instead of n, I put 2. So 4 times 2, that equals 8. For term number 3, That's equals to 4. Instead of n, I put 3, and therefore that's equal 12. Okay, so you can see as you go on and go on that the formula does work. Okay, so let's look at this other pattern as well. All right, so in this pattern, okay, you've got 3 figures as well. Okay, if you check, the first figure has 4 dots. Then the second figure has, for example, if you can count 1, 2, 3, 4, 5, 6, 7 dots. So it has 7 dots. The third figure has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has 10 dots. Okay. So now we're going to put those numbers nicely: 4, 7, and then 10. Okay. There we go. So the first thing we are going to do, right, we want to find a formula for this pattern that we can easily work with, right? We call it the general term. So to find the general term, we're going to say 7 minus 4. Okay, so 4 is term number 1, 7 is term number 2, 10 is term number 3. So 7 minus 4, you get a difference of positive 3. Okay, 10 minus 7, you get a difference of positive 3. So we can now say that 3 is our constant difference. Well done. Okay, then now we can go to our formula. Okay, the general term of the sequence, or the formula for the sequence, is going to come out from, okay, A, the first term, plus n minus 1 times the constant difference. Then we start working out the formula. Okay, A is the first term. The first term is 4, plus n minus 1 remains as it is. The constant difference in this case is 3. All right. So now we're going to work that out. So we got 4. Okay, positive 3 times positive n, that's going to give us positive 3n. Positive 3 again times negative 1, that gives us negative 3. Then we group everything out, and then we're going to get 3n, positive 4, and minus 3. So we can now say the general term is Tn equals to 3n minus, sorry, not minus, plus 1. Okay, so that's the final answer we've found over there. Okay, and you can tell this because if you want to find term number 1, okay, that means term number 1, so we use that formula. Instead of n, we put 1. So term number 1 is therefore going to be 3. Instead of n, we put 1, and then plus 1. Okay, which therefore is going to give us 3 plus 1, right? Because if you say 3 times 1 equals to 3, and then plus 1, and then it ends up giving us a 4. So we are right with that one. The first term is 4. For term number 2, all right, we're gonna say, okay, that is 3 times 2. Instead of n, we put 2, then plus 1, which is therefore equals to 3 times 2 is 6. And then you add 1, you get the answer 7. So we are right by that one. We can see that figure 2 there has 7 dots. And then for term number 3, we can say that this is going to be 3 times, instead of n, we will also put 3 plus 1, and then that gives us 9 plus 1, which gives us 10. So we are right about that. So you can see there that term number 1, 4 dots, number 2, 7 dots, number 3, therefore you're going to get 10 dots, and then term number 4, you would have done the same. So term number 4 is just 3 into 4 plus 1. So 3 times 4 is obviously 12. 12 plus 1 is going to be 13. So you can see you just keep adding a 4 there, and that one will therefore be 17 if you add a 4. Okay, what about term number 10? Okay, that one you need to work it out, because otherwise you're gonna, to jump there might be a little bit challenging. So term number 10 is therefore equals to 3. We use this formula, 3 times 10, then plus 1. Okay, then we're going to 3 times 10 is obviously equals to 30, all right, plus 1. And therefore, this means that term number 10 is going to be equal to 31. All right, so this is why you need to know this formula, because you might be asked about terms that are far from the ones that you've already made or already done. Okay. Okay, so let's look at, for example, number 3 here. Okay, so you've got term number 1. Okay, so term number 1, term number 2, term number 3, and then this is jumped to term number 6, and it jumps to term number 10. Okay, and then this term here, we don't know what it is yet. Okay, but how are you going to find out what it is? The first thing you need to find the formula. Okay, so you've got 5, the numbers 5, 11, 17, and you've got, okay, I'm gonna use those because these are the 3 consecutive terms, right? Term 1, term 2, term 6 is not a consecutive term because there's no term 5. Term 3. So if I said 11 term 2 minus term 1, I'm going to get a 6, positive 6. If I say 17 minus 11, which is term 2 minus term 3, I am going to get also a positive 6. So 6 is my constant difference. Okay, so since 6 is my constant difference, then I'm going to apply my formula. Tn equals to a plus n minus 1 times the constant difference. A is my first term is a 5, plus n minus 1 remains like that, times the constant difference, which is in this case a 6. Okay, so the constant difference will multiply positive that and also multiplies that. Okay, so we'll start off 5 remains as it is, plus, so positive 6 times positive n, that's going to give us positive 6n. And then positive 6, right, times negative 1 is going to give us negative 6. So when everything is simplified, 6n, and then I group positive 5 and negative 6. All right, then the answer from that is going to give me 6n minus 1. So that's the general term formula. Okay, so it means that's the general term formula. All right, so which means, okay, so you can see they've already given me a lot of those terms there. They've given me term number 1 up to term number 6. They've given me their values. Okay, so now when I want to find term number 10, now that I've found my formula for the pattern, I can say term number 10. Okay, so instead of n, I put 10 equals to 6. Then instead of n, I'm going to put 10 as well, then minus 1. So 6 times 10 is 70. Then minus 1, right, is going to give us a 69. Right, so that means term number 10 is a 69. Now here we want to know what term number 70 is equal to. Okay, how do you work that out? Okay, so I mean, not term number 71, we want to know what the number 71 is. Okay, so we have term Tn equals to, we know that it's 6n minus 1. So if we have been given the value of the term, it means that we've been given Tn. So we're going to put, instead of Tn, we'll put 71. And then we want to find what n is. So that's going to be 71 equals to 6n minus 1. So if I take it over here, okay, so basically I need to take all the numbers to one side. So minus 1, because it's minus 1, because it's minusing on that side, when it goes to the other side, it's going to become a positive. And then that's going to be 71, and then plus a 1, and that's going to be equal to 6n, right? Which means now 72 equals to 6n. Now we want to solve for n and find out what term number is that. So since it's 6n, and 6n basically means 6 times n. So if 6 is multiplying n on that side, when it goes to the other side, it's going to divide, or you can just say divide by 6 and then divide by 6. So 72 divided by 6 is basically a 12. So which means 12 equals to n. And so which means in this case, okay, for us to get the numbers, the value of 71, all right, that means that is going to be term number 12. Okay, for 10 we had find that it's 69, right? But for 71, that is term number 12. All right, so that's how you find, for example, the missing term number. Okay, let's look at this as well here. All right, so let's look at this. You've got term number 1, term number 2, term number 3. So you have been given their values, it's 6, 10, and 14. So you've got 6, 10, and 14. Right, so there's T1, T2, T3. So they are term number 1, 2, 3. They are all consecutive terms because the next number from 1 is obviously a 2. The next number from 2 is obviously a 3. That's what we mean by consecutive terms. So if you take a 6 and you subtract it from 10, you're going to get a constant difference of positive 4. You take a 14, you subtract a 10, you're going to get a constant difference of a positive 4. So which means our 4 is our constant difference, D. Okay. Then our 6 is the first number, so that is our first term, A. Our formula says that Tn equals to A plus, and you need to know this formula by head because they will not give it to you in the tests or exams. So times the constant difference. So this means that the general term, okay, equation is going to be A is 6, n minus 1 remain like that. Constant difference is 4, positive 4. So we work that out. General term equals to 6. And then positive 4 times positive n, that's going to give us positive 4n. Positive 4 times negative 1 over there, it's going to give us negative 4. So when we do that, then we're going to do the grouping for n on this side, and then positive 6, and then negative 4 there. So then in the end, we're going to have Tn is 4n. 6 minus 4 is actually a 2, a positive 2. So that's the formula for that pattern. Okay. Right. So now we can prove, for example, if term number 5 is really 22. So if I say term number 5, it means that instead of 5, instead of n, I'm putting 5. So it's going to be 4 into 5 plus 2. So you can see that that's going to be equal to 4 times 5, which is 20, plus a 2, and that gives us a total of 22. So term number 5 is really 22, so which means we have the correct formula. Okay, now let's try and see if we can find the rest. Okay, so term number 20. So term number 20, we'll have to say T20 equals to 4 times 20, right? Because instead of n, we must put 20, then plus 2. So we're going to say 4 times 20, that is 80. Then plus 2, which means that is equal to 82. So that means the missing number there is 82. Okay, and then comes where you have to find what term number is 102. So when they've given you the term number, okay, I mean when they've given you the term value, so the term value is 100, and so which means on our equation, which says Tn equals to 4n plus 2. So instead of Tn, we are going to put 102 equals to 4n plus 2, because we want to find out what that n is. What term number is that? So we start by putting the number on the other side. So towards adding on the other side, when it goes to the other side, it would be a subtraction. So it would be 102 minus a 2, and that's equals to 4n. So that's going to be equal to 100 equals to 4n. So to get n, we divide by 4 and divide by 4. And then in the end, we will find that n equals to, all right, 25. Okay, so which means in this case, that 102 is term number 25. And that's how you work with patterns that have a constant difference. So what you can be asked is to find the term value, or rather the value of the term, and or else they can ask you to find the number of the term, or of the term number. They give you the value of the term and then ask you to find the term number. Just remember that the term value, if you get, they give you the value of the term, okay, that means they've given you Tn. You must, instead of Tn, you must put that value. Okay, if they give you, in the, for example, the term number, you need to go on your equation, and then instead of n, you must put that number. So that is the difference between those two. All right, I hope this video is useful to you. And if it's useful, you can give it a like, thumbs up, and subscribe.